All right. We should be live. Let me know in the chat if everyone can hear me okay, or I need to up the gain. But while I wait for folks to let me know that the audio is all right, this time, no longer do we have the Mary Berry Bubbly. We have the best flavor. We're all done with the Mary Berry Bubbly. We've got, I guess that was the French, the blackberry. Fantastic, folks. Here we go. Oh. DSCH says the audio is good. All right. We're off to the races then. Let's go to tests so I can get that emoji. So I have done 2 streams so far. First one, 8 hours on Saturday. Second one, 5 hours on Sunday. Now it has been a few days. It's Thursday, 5 p.m. in Toronto, Canada, Eastern Standard Time Zone. And in that 3 or 4 days, I have done a number of things. So we have added support for, I think we did that in the 5-hour stream on Sunday. We've added support for dyadic chains. We've done this. We haven't filled out, so we still have this to do. We have a bunch of dyadic functions that have been implemented. We have support for dyadic combinators. We also kind of have support for multi-chains. And we don't really need this anymore. And we don't really need this. So what are we doing in today's stream? Considering that most of the stuff that I wanted to do over the past 2 streams have been done. One, today's to-do. We are going, overview of jelly, jello, and now jellyfish. I guess with a lowercase f. Then we are going to recap everything that I worked on in the last 4 days, which includes quicks, separators, tests, what else? Quicks, separators, maybe that's it. Oh yeah, Combinator, explanation, and maybe even arity notation. And then that's going to be like the first, hopefully 10 minutes. And then what are we going to try to achieve today? We are going to try to get full Combinator tree support. Also, this can probably be a bit bigger. Full Combinator tree support for quicks, separators, and multi-chains. Maybe we'll start with something easy, though, which is color code the prompt expression. And also trace skipping unnecessary traces. Those are 2 easy ones. Maybe we'll do a couple other easy things before, because this last task is going to be pretty difficult. But anyways, let's not get ahead of ourselves. Overview of what we are doing. Also, if you watched the last couple streams, I was using Brave. I don't like Brave. I'm sick of it. And we're back to Opera, which I was using last time I streamed on my Linux box. Now I have a Windows box using WSL2. So we have Jello, which is a Python script that wraps the Jelly programming language. That's the interpreter. I guess we should also add a link here to Jellyfish. And Jelly is according to the author, a code golfing language inspired by J. I think that's unfortunate because even though it's a golfing language, it has some brilliant ideas when it comes to monadic chains, dyadic chains, and multi-chains. And we've basically built this tool that we can type keywords instead of the atoms that come with Jelly. And my script basically converts this step by step into the Jelly expression, evaluates it, and then builds this combinator tree to describe the composition that's happening. Pretty straightforward. Why not Chrome? because I use Chrome for my personal use, and that comes with like all my caches and history and whatnot. And if I'm going to stream, I don't want to, be using my personal browser. I guess technically you can set up like separate instances, but it's just, a greater line of delineation between two if you just, there's no accidentally, I used the wrong instance. And I've always got Chrome. I never close Chrome except for when my computer has to shut down. Anyway, so we've built up this. It's pretty cool. But the newest thing, so that's Jelly, that's Jello, but now we have Jellyfish, which is basically going to be an extension. It's a fork of Jelly, but there are some problems with the Jelly programming language. So every once in a while now when I'm using Jello, because I'm kind of pushing Jelly to the edge of what it's possible, it'll just crash. Sometimes justifiably so. So like this bug, I don't think should crash. It's just, I can show it to you here. So if we want to do 10 iota, that gives us a list from 1 to 10. And then if we call is prime, that should give us a Boolean mask that corresponds to all of the primes in this list. However, it crashes with something prime test. So I'm pretty sure, and I've tested this outside of Jello. It's not that like I'm passing it incorrectly. Actually, like, we can just confirm this. So this is the Jelly expression. If we quit, and then we go Jelly, EUN, this, and 10. Yeah, so like, and it's not like a matter of missing quotations or anything like that. So this is just me crashing the Jelly executable. That's fine. I don't think this was intended to be like a, super robust programming language. It's a code golfing language. That being said, I think something as simple as this should probably pass. I wonder actually what happens if we open Jello again. What if it's like a... Oh yeah. Add this to the stuff that we can talk about. The algorithm advisor. Brilliant. And this is just such a perfect example. So because Jelly is designed, one of the goals of it is to be able to build up very short expressions, there are a lot of atoms that have been added that are just shorter ways using a single atom of expressing something that could already be expressed with 2 atoms. So, for example, +1 takes 2 atoms, but there is an atom for just doing that. And so anytime basically I come across these, I just add it to a little dictionary, and then the algorithm advisor, currently I basically throw an exception and say, you can't move past this, which maybe I should still let it evaluate. There's no reason it couldn't evaluate. But now I do this, and at least it worked up to that point. Anyways, and some of them are actually quite cool. Like, for instance... there is, actually that's wrong. So if I want to go 10 iota, actually let's do 12 iota. Then I want to do chunk 4. And then say I want to sum each of these chunks. There is a quick, aka higher order function, that is the equivalent of summing each of the chunks of a chunked array, which is called chunk fold, which is brilliant. Absolutely. Like, I've had this kind of algorithm in my head for a long time. And so you can change this to, instead of having all this, you just pass the binary operation here. Except that was the wrong order, I believe. It's supposed to be, and actually, no, it was the right order. But this has to be a chunk fold now. Yeah, look at that. Freaking fantastic. And also, they've got not just chunk and chunk fold, but they've got slide and slide fold. The difference being that slide has overlapping windows, whereas chunk does not. So pretty awesome. Honestly, Jelly, I'm pretty sure Jelly is my favorite programming language now. So wonderful. Anyways, so yes, the algorithm advisor. What's another cool one? Yeah, so like if you want to, so for the the sushi for 2 problem, if you're familiar with that, where we have a bunch of 2s, 1s, 2s, 1. The first thing you want to do here is call a function called group, which is going to group the contiguous equal elements into sublists. And then you want to call the length on each of these. But once again, there is a single atom. So instead of calling group len each, you can just call group len. So you go from 3 atoms to 1 atom. A lot of this, when you're using the keywords, 1 doesn't actually make it shorter, and 2 in some of the cases, like +1 is shorter than add 1. But when you're converting it down to these atoms, it actually does make it quite a bit shorter. So anyways, very cool. Let's put this, I guess maybe we should break these apart. What is Jelly used for? It's just a esoteric programming language that people use it for fun. I don't think it's used for anything seriously. I could be wrong about that. So yes, we were doing a recap. And so yes, Jellyfish is now my fork of Jelly where we are going to fix things. And on top of fixing things, we are going to also add some stuff. So basically, Jelly has almost everything. But there are a couple things that Jelly is missing. One of them specifically is the partition modifier that no other array language has. APL has something similar called the partition function, but it's not a modifier. It's not a higher order function. Q's prior, which is basically an n-wise reduction where n is fixed to 2. This is super useful. I'm very surprised that Jelly doesn't have it. And then BQN's under, although we might not need this because of the fact that everything is a single character atom in Jelly. Anyways, what is this? Explain briefly? We need to get rid of that somehow. That's the overview. We're done with the overview. If you've got questions, feel free to leave them in the chat. Now let's do a recap. So we've already recapped Algorithm Advisor. What's the next easiest thing to recap? We can do tests very quickly. So basically, I now have a file called tests, and it's got a bunch of tests. It's not using any framework. I just hand-rolled this stuff. And if I actually haven't run them in a while. Ooh, look at that. Module Jello has no, ooh, yes. We found a bug. So I renamed, where is HOF? Yeah. This has been renamed to Quicks because, so Jelly calls the category in which the higher order functions exist. They call them Quicks. And at one point in my code, I was just calling them higher order functions. But then I realized I should just call them Quicks. So that should probably fix that. Except I also need to zoom out a bit here. What's wrong with this? Jello has no attribute. Oh, I didn't save it. And so yes, now we have one failing test, which is expected at the moment. And anyways, so we can run this. Oh yeah, maybe that should be something we do today as well. Add this to the to-do list. Is add the top 10 tests that are currently missing. But that kind of requires this. So we should put this afterwards if we get to this. Also too, this stream, it could be 30 minutes. I might have to go at some point. It could be 3 hours. We don't know. So if I disappear abruptly, you've been given notice. So we've got tests. The next thing that's pretty cool we can do is the Combinator explainer, and that'll come with arity notation. So if we launch Jello and you type a single question mark, you now have basically a way to explain combinators. So it's got autocomplete. If you hit space, you can just choose which one you want explained. If you go to all, it basically gives you the sample implementation in some kind of like abstract functional language. So for the W combinator, where you're turning a binary function into a unary function by duplicating the argument and passing it twice, you get this nice syntax. Pretty nice, pretty amazing. If you want just a single, combinator explained, ooh, right, because you have to hit this, then go this, and it'll ask you, do you want this in Greek or Latin? That's not the language Greek or Latin, that's the terminology. So Greek is monadic, dyadic, etc. So it'll say the W combinator has the arity notation 1y2, and it's a monadic yielding monadic function with a dyadic function argument, which means that's a mouthful. But what this basically means is the first number here is what the function returns you. So the W combinator returns you a unary function, right? There's only one argument x here. And it's a monadic function because the length of the number of numbers after the y is 1. So the number itself is 2, but the number of numbers is 1. So that means it's a monadic function. It only takes a single argument. And the arity of that argument is equal to whatever the number is, which is dyadic, which makes sense, right? So you're taking a binary function f. This will return you a unary function, aka the 1, and the arity of this function is 2, f. Anyways, if you play around with this, you say you go to, once again, you go to S, and this time we'll do it in Latin, which uses the terms unary, binary, etc. The S combinator has the arity notation 1y, 2, which means it returns you a unary function. It's unary yielding. It itself is a binary function, which means it takes 2 arguments, which you can see here, f and g. Those are the 2 arguments. And the arity of those 2 arguments are 2 and 1. So f is a binary function and g is a unary function. It makes sense once you play around with it. We're calling this arity notation. I also, on combinatorylogic.com, have added a column here for arity notation. Will I be doing Advent encode in Jelly this year? Sure, except we'll do it in Jello, because I'm not going to ever type Jelly. Now that I've got Jello, I will just basically type it in here and, have it convert to whatever it's going to be. Why not? Great idea. Anyways, combinator explanation, arity notation. I might write a paper on this or some kind of explainer at some point. And that brings us to the only other things we need to recap, which are quicks and separators. So probably the easiest way to do this is, first we can go back to this site. So far we have focused on the green category here and the blue category, monads and dyads. However, there is the red category, which is for quicks. Quicks is a umbrella category for many things. The things that I currently care about that are in the quick category are the higher order functions, such as sum, or like scan, reduce, and outer. Currently, if we go to our code and we go to tokens and we come down here to quicks, you can see that these are the only quicks that we have support for. Fold, scan, chunk fold, slide fold, and each. And note that even though our monads and dyads are not ambivalent, but our quicks, we should put a little thing here. Some of the quicks are ambivalent. And that means that basically you can see that they're the same symbol. So depending on whether you call this dyadically or monadically, it's got 2 different meanings. I don't like this, so I'm giving them 2 separate names. So when this is the dyadic, so I guess I should put this, dyadic case, monadic case. Once again, actually we can just do this, can't we? That did not work. Whereas each, I don't think each is ambivalent. So that's quicks. And quicks are interesting in that that's one of the things we're going to need to build support for. So say we do what do we want to do here? We want to do a chunk 5. And now we want, this is just as trivial, right? But we want to do, the length of this is going to be 2. But if we want to get the length of each of them, we have to go len each. And unfortunately, there is a len each. So that's a bad example. So what's another thing that we can do? We want to reverse each. So there is no, or at least I don't have built into my algorithm advisor a reverse each if it exists. But you can see here now that our combinator tree is broken because the way that quicks work is they form functions. So a reverse each is going to be a 1 quick, and then this is going to return you a unary function. So really, what we want for this, if we grab our snipping tool and we go, we want a rectangle, and take this, go to JS Paint. And so what we really want here, whoops, yes. And so actually, let's copy and paste this. So what we really want is going to look something like this. We first want this to, I don't actually know what we want to put here. I guess we can put an H for higher order function. And then over here, we're going to want iota. Oh yeah, and chunk 5. So this actually still is going to be delta, I believe. And then from there, I guess we'll use green. We want this to be the B combinator. And also technically, we should add a subscript P here, because delta, if we go back here and we go to delta, you'll note that delta returns you a binary function, right? But the B combinator is 2 unary functions composed. So really, like, this has a arity of 1, and this needs to have an arity of 1, which this does, because the lower subscript P stands for partial application. Because we're providing this argument here, back here it's basically like saying this y is already provided, so it's partially applied, and what we're returning you is f of g of x with this value already filled in. The point being, though, is that we do not have support for this right now. And I think, oh, actually, I already got rid of those. But when it gets even more complicated, when you have separators as well. So, I mean, that's quicks. Let's go back to our to-do page. That's quicks. And now we need separators. So separators came up when I was trying to solve the maximum consecutive 1 problem. So in this case, it's going to be 2 because 3. And there's several different ways you can solve this. One of them is to split at 0, and then you can go len each, and then max R reduction. So this works, but that's only one of several ways you can do this. The way that I was trying to do it was with a scan, which if you do a plus multiplies with the pi combinator, oh, maybe we should turn that to pi, but we're calling it right for now. And if you do this, what I wanted to do was put this in parentheses and then just pass this to scan, but this does not work. Or actually, it does work. This is the confusing part. It works up until this point. So you can see that basically the multiplication resets your running sum anytime you hit a 0. And as long as you have contiguous 1s, it's going to basically just compute your running sum, which is exactly what we want. And you can see that we are kind of, because we're using scan, which is a quick, our little combinator tree is broken. But as soon as you try to pass this to a max reduction in order to get your answer 3, it breaks. And I couldn't exactly figure out why for a while, and then I realized that there are these things called separators. There is a dyadic separator and a monadic separator, and in this case, basically what we want to do is we want to separate. So for dyadic, you use the colon. For monadic, you use the dot. And this basically will create it starts a new chain. So it says form this to be the phi1 combinator, which clearly my combinator tree does not work for. I have not built in support yet. Once you have the phi1 combinator, this is going to return you. See if we go once again. Now, anytime I need to explain this stuff, I just go here. So if we go to phi1, this is a dyadic yielding triadic function with 3 different dyadic functions. So these are your 3 dyadic functions. And in this case, those dyadic functions are plus, times, and right, which is the pi combinator or the ki combinator. You basically discard the left argument, keep the right argument. And this is going to compose to give you a dyadic function that takes 2 arguments, x and y. And this is the composition pattern. So it applies f first to x and y, h first to x and y, and then passes the results of both of those to your dyadic function g. Pretty straightforward if you understand it. A little confusing if you don't. And anyway, so this separator now, this will form a dyadic function. And scan needs a dyadic function, right? Plus, minus, something like that. And by putting the separator in it here, it manages to basically like process this as a token and then pass it along to scan. And then you'll get what you want. And this also brings up a good point, is that here, where we have just the monadic separator, this is a no-op when it's not followed by anything, right? So, I mean, we can actually go implement this right now. Anytime your expression ends with one of the monadic or dyadic separators, you should just be able to skip this in the trace, right? It doesn't make sense to have this. So actually, let's go do that right now. Let's go, and that's basically separators. I mean, I can show another example if people want to see. But if we go to algorithm, except we need to go to Jelly. Let's zoom out one more, and we come to, this is our trace, right? So we should say if converted expression at I is in why isn't that working? Tokens dot. Is it not tokens? Yeah, what the heck? Autocomplete not working. Then just continue. I guess maybe that's why. It's not supposed to be there. So quit this. Restart. Go to the last expression. And that did not work. Print. Also, we should check. Yeah, we only have the 2 separators right now. Oh, right. We want it to be not in the keywords, but in the atoms. So, I guess if I left, then converted expression, and values, not. Try that one more time. Yeah, so now, well, I think we've got an off by 1 error. Yeah, it's I minus 1. In which case we also don't need this check, right? Yeah, there we go. So now the jelly expression that ends in a separator is skipped because we don't need to see that one. And arguably also, we don't need to see any of these first 3 because because of the fact that we've put a separator here to build up this phi1 combinator, the first one we care about is this one. So really, these are the only two steps that we care about. So we're going to fix that. All right. Fantastic. Let's go commit that change. All right, we've got a bug fix first. Actually, let's just run rough git diff test git add I mean, can we do more right now? So, I mean, let's focus on, I mean, we can actually, we can add the comments with a different, so, I mean, the same thing that we did originally for quicks. We actually, I mean, we said we were going to do some easy stuff first. What was the easy stuff we said we were going to do? Color code, I mean, trace skipping. So, I mean, we partially, do I have a yellow? I do. So, let's get rid of this stuff. Let's add this down to our to-do list. And just call this to-do now. So we'll come back to completing this, but let's do that one. So yeah, let's go and commit that then. Actually, let's add everything. We're going to call this actually, what is the Gitmoji for docs? Is it memo? Yeah. Memo plus, is it a cleanup? Small fix plus comments. Oh, right. And depending on how far we get through this stream, we can even make some changes to Jellyfish. Like I think prior is the easiest, and then I also want partition, which should be pretty easy as well. Easiest productivity fix, rename today's to-do to to-do. Yeah. I mean, you got to take the small wins. All right, first things first, let's go do this. Which basically, so what I want by this is when I type something in, I want this to be color coded. And let's take a look. What is should we just match the jelly site? So green is monad, blue is dyad, and separator is white, quick is red. So green equals monad, blue equals dyad, red equals quick, and white equals separator. And honestly, this should be a very minimally invasive change. Because it all happens quite simply. I mean, does it happen in the jelly code? I guess it does. Wait, except this is green. where does this... Right, user input. This is where it happens right here. So, I mean, we can just move this down here. Although, do we want it up here? We kind of do. Which is tricky. Right, actually. Put this in here. Ooh. Yeah, we don't need to color it in the case that it's an error. And then once we have it split, we no longer want to print, we want to print args, and then, but this is all, so technically, oh, it hasn't been split yet, so perfect. We will split it in a sec. So let's just type this for now and see that it gives us what we want. Right, so this is the same, so we're in the same state now. So now if we go dot split, this will give us a list with all the words, which is what we want. And then we want a little function. Ooh, except that's the problem, is that or is it a problem? Maybe it's not a problem. Like in the past when we've been doing stuff with the draw cprint function where you need to pass, because this actually, yeah, this is a problem because this does not return you a string, right? It's a void function. So if you want to use the cprint function, you have to use a for loop. However, we don't need to use a for loop. We could create, let's take this. Call it a keyword color. And I actually never know what the type of color is. And then we, if k, actually we can just steal this from up here, right? So if it's monadic, we want for.green. If it's dyadic, we want for.blue. If it's quick, we want for.red. And if it's a separate, actually, if it's anything else, we just want return for.white. Now, the interesting thing here is, because basically we've got a list of like A, B, C. We want to split this, or it's already going to be split. And then we want to insert the color, you know, after each one. So we're going to go ask, oh, I need to log into ChatGPT in Opera. Yeah, let's go do this off screen. Uh-oh, I need my password? Why don't they send me an email? There we go. They're going to send me an email. And ChatGPT is back. Is there a way, zoom this in for you folks, way to interleave two lists or two lists, you know, 1, 2, 3, and 4, 5, 6 to be 1, 4, 2, 5, 3, 6. What? Zip for pair in zip. That's not right, is it? That's not right. ChatGPT never gets this stuff wrong. One, 2, 3 we'll call X. Y we'll call 4, 5, 6. Pair for... It's going to give you a list of tuples, no? Although they did have this for item in pair. Oh, so they have a doubly nested. Okay, yeah, so this is what I was thinking in my head. But they have a for item in pair. All right. Faith is restored. I don't want to do this, though. Is there a built-in in iter tools or more? Iter tools. Yeah, there we go. Thank you. Can I ask ChatGPT? That's true. We haven't recorded an episode of my running podcast for a couple months. Guaranteed by January, if not sooner. So maybe we'll do one end of November, mid-December. We've both been busy, says the guy who did, close to 15, 16 hours of streams at this point. So let's come back here. We're going to do this. And so what I want is and then I want list of, do I even actually need the, I probably do, because it's going to give you the iterable thing. Round robin of keywords, and then I want to map. I can never remember which one goes first. What is it? It actually tells me right there. Function. So the function that I want is keyword color, and then keywords. And I need to join this, right? So actually I don't need this in a list. I need this in a join. I'm not actually positive this will work. It could, though. If you're able to concatenate the colors and the strings. It uses the plus operator, so I don't see why this wouldn't work. Oops. Here we go, folks. Round. What was I even trying to spell there? C print. I mean, it actually is working to a certain extent. Except it's wrong. It's off by 1. I mean, those are the colors, obviously. And it needs to be before is the problem. Which I probably should have been able to guess without actually printing that stuff out. Look at that, folks. Why is it... Do I not need, Oh. We definitely need spaces. Why is it so spaced, though? Right? Oh, yeah. Yeah. All right, that makes sense. So what's happening is because I'm joining. So this is actually. So let me finish my thought. So I have basically a list of keywords, and I'm inserting the colors before each one of the keywords to color it. But that's going to give me, if this is n, it's going to give me a list of 2 times n items. So for every single space, technically it's adding an extra space for the color, which I don't want. So a tricky way to fix this would be to get rid of our join method and just add to our round robin a list of spaces. Actually, I wonder if just having a single space does it. And it cycles. That would be amazing if it does. Right, but then you still need to join it, which is kind of irritating. It does not. It short circuits. So you need to multiply this by the length of keywords, which at this point is getting a little bit unwieldy. Unterminated string literal. Huh? Line 119. Does it not like that I braked? There's no way that's the problem. Apparently that is the problem. What the F? Iter tools repeat, perhaps? I mean, this is short enough. But it literally does not, it doesn't break this. All right, well, it doesn't need to be broken. That's fine. And let's get rid of this bright screen. Anyways, this is done. Let's, what are we missing here? Separator's white. I guess we have all the colors there. Feels like there should be some yellow or something, but my recollection is that you can break only between parentheses, but not the... Not sure how that works inside an F string. Only reason I type the hyphen hyphen is because YouTube has a ridiculous UI feature that covers the end of the last, most recent comment. All right, this is working. I mean, this part's working. I kind of almost want like an extra line break now, because now that the colors are on top of this stuff, it kind of disappears, you know? Yeah, it's better. Although, yeah, the blue's fine. It's kind of a little bit dark. Let's do something else, though. What have we... when was the last time we had... Yeah. Would be kind of nice, too, if we put each one of... That's actually... We should add that to our to-do list. Should we do that right now as well? Yeah. Well, first let's commit this. Let's see how big a change it was. I mean, pretty small. Keyword coloring for input expression. For your readability, dot join keyword color plus keyword for keyword and keywords. Yeah, why didn't I think about that? And then actually, you don't even need keywords. And we can just call this K. The fact that we've got keyword color here tells us what the K is. Yeah, that's very nice. I like that much better. And we can also then go get rid of that. Thank you, Nathaniel. Let's just go make sure. Yeah. Very nice. clean up keyword color and code. All right, let's go back to our to-do list. We are now done this, but now I also want to, and we can get rid of this. I want to add the jelly atoms below each keyword. Seeing as we already have a space there, right, that is not getting used. So what do I mean? I want, I mean, this one, it's going to be less meaningful. Basically, I want each of these underneath this, which also should be pretty easy. What do you need to do? You need to figure out the length. It's actually a neat algorithm. You have to figure out the length of each one and then build a string. I mean, the easiest thing to do would just be to have it left justified, but I would prefer to have it centered as much as possible. Also, I need another bubbly. I'll be back. I wonder if ChatGPT, you could explain that. I have two strings. Is there something wrong with the spacing on the dotted lines? Yes, that is. Currently, I don't have support in the Combinator tree for SQ. This should really be. We did this earlier with another one, but we can do it again. No, where I want that. So if we come here, copy this, go to Opera. So we did this one earlier, but we can do another one of these. So really, the way that I want this to format is I want this to form the phi one. Then I want this to form a higher order function. And then I want blue, this to form the B combinator. So it's got the B right. Everything else here, though, is wrong. And that's just currently because I don't have any logic to handle this stuff. So yeah, we'll get to that in a sec. One moment, though. I need to... reply to a message. Where are we at, too? We're at the hour mark? That's pretty good. All right, so we are going to get to hopefully doing this if I don't have to leave. But before we do that, let us go back to our code. Should we ask ChatGPT first? So basically, I want I mean, it's almost harder to explain it to ChatGPT than it is just to code it yourself. Yeah, let's just do it ourselves. What does the chat think? So we want to print, you know, spaced jelly atoms. This is going to compose of an indent equals, what is that? Times 2 plus length of args plus 4. And we'll put this in a function. Indent plus test. That is exactly correct. And now we need to what was your question? I think I missed it. If you re-ask it, I will answer. And now we need the, so I guess actually we can just call this indent plus jelly spaced atoms. And then how we're going to do this, it's going to be this dot join, and then we basically want a center atom for k in expr dot split. Oh yeah, thanks. I mean, there's no real question in there, but I appreciate that you're enjoying the podcast. The one tomorrow, it's a continuation of our conversation with Richard. It's pretty interesting. Talk about what makes a language functional, and Richard's new programming language called Rock. For folks that haven't heard of it, rocklang.org. It's got a new fancy website, pretty shiny. You can, you know, test stuff in the browser. Pretty cool. Fast, functional, friendly. Check it out if you're interested. Oh yeah, you're like that's, I mean, that's a golden place to be if you know, my favorite podcast or one of my favorite podcasts of all time was Functional Geekery. But this podcast hasn't aired an episode in like over a year. But I was listening to this back in 2000. Was it 18? I think it was 2018, the summer of 2018, right after I had moved to Silicon Valley. And I think I got through all of them in like a month. And I can like distinctly remember running on the treadmill at lunch when I was at Amazon and going out for runs when the weather was nice. And I was so sad when I ran through the backlog, or finished the backlog, because I used to listen to like, you know, a couple a day. And then once you're done, you have to wait till a new one comes out, and that can be infrequent. Anyways, if anyone in the chat looking for another good podcast, Oh yeah, the Steve Jobs. I mean, yeah, that is one of the. So if, yeah, I didn't plug ADSP the podcast. Usually I plug at the top of this stuff. Arraycast. So I've got two different podcasts. We are at episode 157 as tomorrow, and in the chat is being mentioned Steve Jobs. Yeah, so this episode here is probably one of the most entertaining by far. I mean, basically all of Sean Parent's episodes are fantastic. There's also one where, actually, I think if you just go to the tags, you can search for Sean Parent, and this was not it. Was it the first one we had him on? I'll actually have to figure it out. One of these episodes, he talks about how he thought he was going to get fired from Adobe, and he got called into the CEO's office, John Warnock. And then John Warnock ended up calling Steve Jobs and telling him not that Sean was getting fired, but that they weren't going to work with him anymore because he was being not very nice. Yeah, I'm also like it's a crazy, no spoilers for folks, but no one ends up getting injured, which is good. The second one, you mean this episode 18? Yeah, probably. Although that's a pretty bad description. We finished part 2 of our interview, and don't say anything about John Warnock. Anyways, check out the podcast. We also have another podcast, Arraycast, if you like these kind of streams, check out Arraycast. Honestly, it's the better of the two podcasts, but it's just about a more niche topic. So less people are interested. Don't tell Bryce I said that, though. He'll be upset. Anyways, getting off track here. Coming back here. So we need this. We need this function center atom. What is going on here? And this is going to be a string. And this is going to return us a string. And actually, we're going to need an int as well. And then we want half equals n divided by 2. And then we just want to return maybe it's just easier to build it up like this. Actually, we can and then I mean, if that worked, that's pretty crazy. Right. Right. I have a function called toJelly. So actually, this is a keyword, and we don't need n. N is just the length of our keyword. And ooh, some of these atoms actually take up 2 spaces though. Huh. Why did my indent get so messed up? Also, let's get rid of this now. And let's draw.cprint this with for.yellow and true. Yeah, what's wrong with our 25? That seems about right. Expr.split. It's almost like there's 2 indents happening. Is that what's happening? Yes. Right, and we don't, do we need to join? I mean, we should actually. 1 0 1 0 1 0. But there's an extra space in each one of these. It's actually not odd, it's even, isn't it? We're getting closer. So that is definitely right. So what happened here? Right, it should be n minus 1 divided by 2. There we go. Nice. There we go. Let's clean this up a bit, though. Should we put both this stuff in function? Both this... What do we name this? Should we put it in the draw module? Draw dot spaced jelly atoms. And this is going to need args and expr. Go over to draw. Right. Oh, yeah. Let's just keep it in here then. Pretty good. Just switching to double quotes. This is add spaced jelly atoms under keywords. All right, pretty good. Let's go to our to-do. So I think now we're to the hard stuff. So we're at 1 hour and 20 minutes. Who knows how far we'll get through this before I have to go. But yes, I mean, let's go back here. So what's the order, the steps that we need to do? We have to first add support for displaying quicks. I mean, the steps that will separators will always be first. So actually, let's build up an expression. There's an alternative statement. So this is the maximum consecutive ones problem. But there's another one that is the longest LCIS. This is LCIS here, the longest contiguous increasing subsequence. Then there's a couple different ways you can do this. If we get the difference of adjacent elements, check which ones are greater than 0. Then we can split at 0. And then we can do our len each, and then take our max reduction. So note that this combinator tree all works. No use of any quicks or any separators. However, if we go back to use the scan solution that we used, because basically we've converted at this point our sequence of integers into a sequence of zeros and ones. And now this is just, once again, the maximum consecutive ones problem. So if we try to do a plus times ki combinator, aka r, aka pi, once again, this works up until now. You know, technically that's our answer. But as soon as we try and go max r, oh, actually, wait, what the hell? How does this work? Oh. And actually, we're supposed to do scan here. We're not supposed to. What is happening here? A delta, that's this, followed by 3 sigmas. So is it, I mean, so let's walk through this. The first binary operation is plus, which is going to just add this sequence of ones and zeros to our initial sequence, which is how you get this. That shouldn't be helpful. Then you have times, which is going to multiply this by our initial sequence. Also should not be helpful. Oh, yeah. So this is nonsense. What the problem is here is that if I do this, now it's going to have 14. And if I do max r here, then the answer is going to be 14 when the answer should be 4. Okay, so we have clarified that that makes no sense. And then when you do scan here, this is just nonsense. So what you need to do is you need to use the dyadic separator and the monadic separator. So if you do just the dyadic, once again, you're in the case where this works. But if you try to follow this by a max reduction, So wait. Let's go back to our MCOs. Why? Why does this need a magnetic separator, but this only needs a dyadic separator? Also, actually, once again, I think this is wrong. This should not be 2, 3, 4. This should be 1, 1, 2, 3. And if, although, I mean, if you put the magnetic separator in, you then get what I expect. And then you need to add 1 to this. But why does this actually also gives you the right answer? So up until this, we get this. So this is going to be double this sequence. Right? Huh. Interesting. It looks like what's happening here is you're actually able to add that's unfortunate. Let's go quickly change our code. So what's the more if we turn this into a set? Can you do set in? is subset. There's also a ooh. If it's a string though, how to turn string into cars in Python. And then we go 0, 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9. Huh? Is whoops. Whoa. Right. I mean, we can fix that later. It's basically going through this character by character, as you can see. And when you have an incomplete array, it's not happy. However, my point still is that you're going to end up with 2, 4, 3, which is the case. Hey, C4 Tubo. The jelly journey does continue, or Jello journey. And I will, you probably, if you're just joining, you will have missed that I have forked Jelly and am now calling my extension language. We've made no changes yet, but we will make some changes because there are some things missing from the Jelly language. And it's also got a lot of rough edges, and I have crashed the Jelly interpreter many a time at this point. But we'll get to that later. But the point is yes, that you can add irregularly lengthed lists in Jelly, clearly, which is what's happening here. So the plus adds it. The times does the same thing. Right. I don't actually know what right. I think this changes now that we have a 222 train. But once we hit the scan, I guess that gives us this. And this was the equivalent of a plus times, which is a 2-2 train. Well, instead of figuring out why this, you know what? We'll add a, nope. Or I should just call it understand. But we are going to assume for the moment that the solution we want uses both the dyadic and the monadic separator, because at least I understand how this is supposed to be parsed. Yeah, so 2 separators. Yeah, so let's go to JS Paint again. And now, what do we expect for this? So first things first is we do separators. So we want this to be phi 1. This is going to be delta. Oh yeah, we got to add that subscript. We should go do that quickly. Subscript P. Thank you. And I guess it's just in here, right? Yeah. In fact, both of these are subscript P for partially applied. Anything actually that has a 0 in it should get a subscript. Let's go see how that looks now. Yeah, it looks pretty good. Although, now we're going to need to go Combinator arity. Didn't we used to have a function for getting the length or the number of it's not the arity. I guess we can just like, how many times does this show up? That's it, eh? Huh. I swear to God, we adjusted for the did we not? What if you have actually, let's just start something new. What if we have 1, 2, and then the phi combinator is going to be phi 1 combinator is just going to be plus, plus, plus. And then what do we do? Plus, plus again. Yeah, somehow that's adjusted for. It must be, well, if it's using the length of it, though. Is E wrong? My guess is that E is wrong. So E oh wait, it's in the print bars, is it not? Combinator width. So lost. Huh. I think this is completely a mistake, and this should just be this. Yeah. That I think I must have. I mean, it's a well-named function, but I must have looked at the body of it and said, "Oh, this is what I want." But really, there's a bug fix that massively needs to be there. All right, so we need to update this stuff everywhere. Let's go back to that other one now. Yeah, that works now as well. Ooh, except you know what's not going to work? All our tests. Because anywhere there is a E, epsilon, D, or delta. All gonna be wrong. Slide fold. And we're back to normal. Actually, let's just do a... let's do it on delta. Okay. Okay. So there's a bug fix in there. Renaming. Actually, let's do this. Look at that. So many emojis. I guess we should update. This photo really needs to be updated as well. What is it? It's... plus... Actually, I think if we do... Yeah. Pretty cool. All right, where were we? I guess we were actually back here. We added that P now. And this then is going to be, you know, higher order function application, or yeah, higher order function forming. Then this is going to be the B1 combinate, the B combinator. Yeah. So if we can get this example to work here, it'll be laughing. And actually, what's the let's fix this. This needs to look on the same level as, and this is phi 1. So now that we have this diagram, how does this work? You always process separators first. Then you process quicks. So yeah, 1 separator, 2 quicks. And then once we have, so separators will always give you an initial level if you have them. Then, so this is number 1. Then quicks, which we do twice, we will have to do multiple passes, because you can potentially have multiple quicks back to back, right? You can have, so say if we have 10 iota chunk 5, and then if I want to do a plus scan on each of these, I would do a plus scan. Actually, what does it do if I do this? Plus scan, look at that. Actually, so we don't want to do a plus scan because we have a built-in. So if we want to do a multiply scan, what does that do? I don't actually think that does anything, but if we do each, it should definitely work. I mean, well, clearly it did something, right? The 1, 2, 3, 4 looks like it stays the same. This one, oh, so it must be a leading axis scan. Although that doesn't really make, yeah, 6 times 1, 7 times 2 is 14. So yeah, it's a leading axis scan. But we don't want to do it down the columns. We want to do it in via the rows. And so by doing this each, we now have 2 scans on each of them. And so the point being here is that we have a quick. So, you know, how would this one look? JS Paint. And take this, put it here. So once again, we do separators first. There's no separators. Therefore, now we're going to do quicks. This quick is a scan, so it takes a binary operation. This quick is an each, takes a unary operation, which is this quick forms. And then we're going to go over here. 1 iota chunk 5. This is going to be delta P, which forms a unary function. And then on top of all this is going to be the B combinator. Hopefully that makes sense. All right, I'm going to take a short break, and then I'll be back in a couple minutes. I've actually, so let's see if supposedly I always check the option that never puts ads because I don't care. But I think I set it up. I mean, I always set it up that I can manually insert ads. So let's see. Let's see if this works. Add inserted. Well, is there an actual ad playing? Nobody knows. Right, well, hopefully there's an ad playing. Well, I take a short break. All right. Was there an ad? Is anybody able to tell me? I don't know. Maybe there's still an ad. I went and got a protein bar. There's absolutely nothing about this interface that has let me know whether or not there was actually an ad or not. All right. No worries. We know what we have to do, though, now. Which example should we start with? Should we start with this one? Should we just go for broke? I said we just go for broke. And we're going to do this is the solution to the longest contiguous increasing subsequence, LCIS. So I currently have some code to process quicks, but it is pretty hacky. So it's quite arbitrary. All right, unmuted now that I'm done eating my protein bar. So 222 is phi 1, and 120 is delta. So if we just split on S, and do everything but the last item, so we don't do this, but we process this, this is going to turn into a 1. This is going to turn into a 2. Then on the next phase of processing quicks, so then we're going to end up, after this, we're going to end up with a 1, 2, Q, 1. And if we then process this, this will become a 1. Oop. Actually, let's make this a different color. And then this becomes a 1, 1, 1. And that's when we end up with a BB. So really the only tricky part. This first part is easy. Splitting and then drawing each of these, not a problem. It is a problem. Because I guess we have to do this all at once, right? I mean, it's actually not too tricky. We just identify the starting and end points of each of these. And then we'll get these values here. It is a tricky problem though, to kind of do linearly without building up like a graph. Step one though. Step one, let's just do baby steps. Let's do the purple here. Purple's easy. Ish. So let's just call this process separators. And what do we actually want here? It's actually easier than it looks. Because remember, these are only 2 lines. So yeah, I don't even think it should be, it shouldn't even be here. It should be in draw. So maybe there should just be a, yeah, process separators here. And actually there's the single tree function. Because the single tree could be multiple trees. And what if we, separators is 4? I mean, to do we should probably just do it right now. Should we? Mm. Mm. What's the one we're doing right now? Deltas? Separator. Not defined. Oh, did I not? No, I did. Also, is that how you spell? I'm going crazy here. Separator, yeah. Oh. Found you. Oh, did I not pass the... You can't split a list. I mean, technically I have my own split, don't I? I have a split and keep. I don't really want to keep though, but we'll do it for the moment. And this works on both wait, do we have utils in here? We do. Huh? Oh. What did I call it? Split keep. Right. It does not work on lists. Wow. Come on. Brutal. All right, I need another bubbly. I'm back. All right, good to know that it's working on your computer. I can't believe there's not a list split function in Python. Pretty bad if you ask me. I mean, this is what we want. I mean, why is it actually printing? Right, because we always still have the same thing. So, I mean, that's correct. Also, I'm freezing. I need a hoodie. The La Jolla hoodie has been acquired. And also, now that I think about it, there's nothing actually preventing the separated chains from being much more complicated than this, right? You could have like a full-blown Combinator tree in here. I guess for now we'll just support single level trees. Yeah. Okay, so now that we've got this, you know, for chain in up to the last one, we are going to call, we're going to see what happens when we call this. I mean, we don't actually now at this point this is, I don't want to have to pass all this garbage around, so. And so this is chain. This is C. And then we're going to go C. We're going to just pass in none for the moment. Damn. This one, actually, yes, so let's enumerate. Ooh, and we need to know actually if it's dyadic or monadic. Ooh. Because we need to know, well, so first of all, we need to go here. I think we should separate these out. So actually just do this. So special dot quick needs to be special it could be a rank 2 array. Yeah, probably. There's at this point, there's no way we're gonna finish this tonight, but it'll be a good start. And then we need special dot each to be quick dot each. And then we need, actually the other ones we need to go check. We're gonna need separator and quick. This is gonna be, ooh. come back to this. Wait, what was this one? Oh yeah, this just needs to be deleted. Mm-hmm. I think we should just kill this list split thing. For now, we can come back to it. For and then yeah, if ooh, accept. That's fine, we've got dynamic typing, I guess. I might have to go in 5 minutes or so. Maybe, maybe not. Subchain type. Indent, we'll just call it indent. Yeah, that's right. We never did that to do of separating these two things. I mean, what do we need the CCS again for? Yeah, printing bars. So I think we can omit this for now. And then arity doesn't get appended. We'll go to the next one. I mean, there's a chance there's some semblance of right. We didn't finish. If tokens. Not special, separator. Should really be building a convenience function, but we'll do that in a bit. All right, fine. We're back, giving it a shot. Infinite loop. Right. We do not need a while loop here if and actually we should do it like this. Local variable C. What the hell? Well, that's correct. So, step one, right? Yeah, let's print. Ah. That should improve things a little bit. That is wrong. Let's not quick info. So this is incorrect. This should be dyadic, which is why the 2 is registering as a W, which is what I thought. So why is that? Let's type arity. Arity somehow is monadic. This is a dyadic, so that means we're doing something wrong over here. Return dyadic here. This is saved. Print chain. So we've got separator dyadic. Oh, right. It's the one from before, not the one after. So we actually are just, yeah. If it's none, then it's chain type. Else it's separator. And then we set separator to arity. That should do the trick. All right, well, there we go. I mean, so at this point, we've got this and we've got this. They're one on top of each other. So what is the easiest way My first thought is, I mean, these are just two strings, right? You could technically concatenate them. I mean, we're just printing them to the screen right now, but how hard would it be to turn this? Right, that effectively is a string. That effectively is a string. And we're only calling this in two places, so we could really just stringify this, print in that location by joining and it's easy enough to take the indent out. And then we can make a multi-tree where if given multiple strings representing 1, 2, 3, it'll just concat the first set of strings, the second set of strings, and then you'll be done. But let's think about this a little bit more. So we do that when we get our strings. We'll need some way to store this index and this index. I mean, this will work. The problem is that, you know, I had said earlier that we were going to limit this to single level trees, but that doesn't really scale. I thought we tried this earlier. We didn't like it at all. Man, what the heck? I don't even remember how to run a Ruby file. Ruby Yeah, this is not. What I want is too boutique. Libraries are not going to help. We're going to have to hand roll this. And we're just going to need to make it more robust. Yeah, the hard part is just the recursive nature of it. You know, it was fine when we're building out to the right here. But as soon as you can have these basically arbitrarily nested at any point in the expression because of separators and or quicks, you can't use this kind of linear flow. And so you just have to do it piecemeal. I mean, I was trying to think, is there like a stepping stone? Because what we did for the quicks at first was just consume the quicks, replace the arity chain with the simplified version, and then display that, and don't worry about displaying the subtrees. Unfortunately, for this example, I mean, the most simplified is just BB, and that's not helpful. I mean, maybe we should just go back to what I was We might be shooting ourselves in the foot here, but that's okay. So let's do this first things first. So let's see if we can, if we comment all this out, does our program just go back to working? Well, like the way it was before? Oh, I really like this. It's quite nice. So we have. So let's see if we can just refactor. In fact, I mean, what are how much of this code? Yeah, I agree. Let's close some of these tabs here. Close this, close this, close this, close this. Yeah, love the color highlighting. Love the atoms underneath the keywords. I mean, what's on our to-do list? Our to-do list is, I think it's mainly just this now and a couple follow-up things. Yeah, add the tests and then work on Jellyfish. But I mean, this is the most important right now. So, I mean, the steps right now, let's turn, what's the name of the function? It's over here, draw. Let's turn, yeah, single tree. To return strings instead of print. Then is printing out separate from tree building at this point? No, they're intertwined, which maybe at some point they will be untangled and it'll all be building and then just a single print at the end. I mean, the initial reason that we printed while building is because when you print, you have to kind of concatenate these colors. But we just showed earlier in the stream that you can build up a string that basically injects the colors into the string, so then you're good to go. Yeah, let me know how that goes, C4Tubo. But yeah, once we have this, I mean, we can quickly then solve the single level separator processing. Then once we've done this, we want to refactor CCS into a different function. And I think once we have these two things, we're going to be in a pretty good place. So we should just focus on this. So The question is here is, should we see if we can commit some of this code right now? And I think the answer is yes. Let's, usually you could do this just patch-wise, but because I know this is the only code, and this is, I didn't even need to, or did I need to delete it? I don't know. I guess this is actually just refactoring. Adding quick and separator enums. And you know what? Let's come back here, add this in, but then we're just gonna stash this. And then we're gonna go to refactor this. So. We need to this is this. Thanks, man. Good night to you too. I mean, I don't think that there we go. That was the problem. And I think we need a new line at the end of that, maybe. Maybe not, actually. Actually, just call it bars. I mean, I think that's actually working. It is indeed. That's awesome. All right, step 1 done. So now we just need to concatenate this into the following. Do the same thing on the next one. Beautiful. Beautiful. And now we can actually just return this as a tuple, a list. We will do a tuple for now. And then this is now returning a 2-tuple of strings. And this is that was so easy. I thought that was going to be trickier than that. Well, I didn't think it was going to be that tricky, but that was phenomenally easy. And now when we go to single tree, we need to print. Although, can you join on a tuple? I would assume you can. But I actually don't know. Print. Ooh. We are still bundling the indent in here though, so look at that. Unbelievable. Oh, okay. So we need to get rid of the indent. Which is easy. And we're actually so close. But what I want is a little print. We might even delete this at some point, but just for the moment, print single tree, and then the tree is going to be a 2-tuple of strings. Not actually sure if you're allowed to do that. And then indent is going to be an int. So if we go back down to one of these, we change this to single tree, and then we get that. Go back to where we were. Ooh, ooh. Yeah, I guess we got rid of the print statement, didn't we? I guess it's better to like that. So now we can delete indent from this. Delete indent from that. Delete indent as parameter. There's no way I got that right. Yeah. Got pretty close though, considering that works. All right, I think that's enough to commit. Ooh. Whoops. Ooh, haven't even handled this case. But it's already handled now. And we don't need that anymore. And we don't need that anymore. Actually, let's ooh. Iota, odd, index plus fold. I think I actually did get rid of that. I did have a check for that at one point, and then I got rid of it. But I think yeah, I broke this. So this actually wasn't even a recent change. This was... Maybe. I definitely have to think about that more. And what is this supposed to be? Triple B, yeah. Problem is somehow I've messed up this process quicks. So if I print chain arity post quick, it's not going to be 1111, which is what it should be. Yeah, it's 1112 quick. Why is it 3 comma? See, it's not pattern matching on 2, 3. These are definitely supposed to have commas, right? Maybe they're not. Oh, I gotta check that. Oh, they're not. Scheisse. How is, I mean, pros and cons of Python. Somehow my code was not crashing ridiculously even with that oversight. However, it's still... Hmm? Hmm. That's my bug. Well, we gotta go turn all this stuff off now. Still missing a couple. This is in draw. No, it's what? What's the problem here then? Right, because some of them. We're back. We're back to where we were. What was the other one that we had? We had That was deltas as well. Maybe we should just get rid of this. Or just turn it into a print. Just as a reminder. All right, let's go fix this unpacking problem. I mean, it's line 84 of Jello. Oh, what? So print. Huh? This is a list of, all right, you can't separate the, right, so the separator, so if not is instance of And so what we had before was right. But why all of a sudden? I just realized this doesn't even work anyways. Oh. I mean, that's why. All right, I've got maybe 10 minutes left. The problem here is that these are successively supposed to do checks, but clearly if we're replacing a sublist of a list with a tuple, the successive ones aren't going to check. And because we have a quick right after a separator, I mean, in general, we already don't handle that case. Which is why this is failing. I mean, yeah. Let's just hack something in, but the key is here that I think you just need to process. Quicks after separators, and we're not doing any of that right now. So where is it upset? It's upset in here. Yeah, is tuple a thing? Yeah, actually, I don't know why we just weren't using tuple. All right. All right, so now that we got this back, let's just run this again. Separator not defined. So we've got that. And now, is there a way to... I think you can definitely do this in like a single down sweep. At least that's what I'm attempting to do. I mean, we're very close now. These we have our 2 strings. And the thing I'm thinking about right now is, do we want to change the combinator tree to return a string? Because right now that would not honestly be too bad, I think. But the easier hack would be to just pass some flag in. Like a mode flag. I mean, we could just do it right now is true and then false everywhere else. And then we come back out here. We pass false here. Pass false here. And then this is our, you know, separator mode. And if we're in separator mode, it's not actually exactly what we want to do. Call it no ST break, which stands for single tree break. And I know there's a count method, but is there a count multiple method? Both pretty bad. You watch all my videos at work? Really? That's good to hear. I would not have ever imagined that my videos were being watched at a corporate place. I mean, it is fun. Where do you work? Oh, I see. You force them to watch it. All right, that checks out a little bit more. So if we hit Influtive Corp. In Toronto. Hey, look at that. Fellow, well, I'm not sure if you're Canadian, but fellow Canadian resident at least. And then if we go sep count, as long as it's greater than 0. And then when we go print single tree, actually, wait, that's not going to work at all, is it? We need to get both. We need to get both pairs of strings back. Yeah, never mind. So we have to do the latter. We have to return strings from their Combinator tree and then mess around with those. What are we at? 4 hours plus? I still got some bubbly. So what is that collectively? 8 plus 5 is 13, plus 4 is 17. All right, well, let's revert all those changes. Kill this. All right, we're back. Well, maybe this will be... Ooh. I was about to say, maybe it'll be... as painless as it was refactoring the single tree function. But... we're already returning something. Do I want to refactor that or save that for another stream? Because basically, we did this. We are very close to getting this. But now it has become evident that we need this, which we currently don't have. I mean, let's see. Let's start, and then if I deem it to be too tricky, so let's just copy this, call it Combinator chain sequence. You can comment that out for now. Anything that is printing, we don't need. Anything that is calculating adjustments and widths, we don't need. So we don't need this. We don't need indent. We do need the chain type. So wait, we don't need this. We don't need indent. What do we use the initial call for? We might need that. We don't need that. We need all of this stuff. We do need initial call. Output we don't need. CCS. I don't think we need. Quick info. Don't think we need. So I think that might be it. Should we delete this for now? We might need some. We might need to refactor out some. So it should be 1, 2, 3, 4. 1, 2, 3, 4. If that worked, oh boy. Oops. So we don't need that. Let's close some of this. We don't need this. We don't need this. So chain type. Initial call is true. And that. If this works, we should have done this a long time ago. And probably, yeah, I don't know if we should leave it in the W is width, so we missed a spot. Apparently we do need W. Why do we need W? Right, this is no longer combinator tree, it is combinator chain sequence. Oh my god, did that work? That was freaking awesome, folks. Nice. Which means, well, first off, let's it's dangerous that we have I mean, this is a nice piece of logic to factor out. Whoops. We call this beautiful. Beautiful. And all we need is chain. Good day to you as well, Royal. And this is going to be a list of int. So now we can come back here. C equals this. C equals this. is magnetic. Oh yeah, we do need name C is not defined. Clearly I missed a spot. Right, we don't need this anymore. Perfect. So now we're going to need we need to change single tree into a list. That's step one. Step two is we need to no longer print single tree. And also now we can get rid of this output stuff, which is nice. Because the only reason we had that we don't need to return C here. We can get rid of output. We can get rid of output. We can go over here and we can get rid of one of these as output. And this is the base case. Part of me doesn't really know what we should do with the indent. What should we do? Should we bundle it? Create a list of 3 tuples? Or a nested tuple that bundles the indent? Or do we actually just go back to printing the indent? So actually, let's go back to beautiful. Now, instead of a print single tree function, we need a this is going to be a list of int string. That's all we need. And for this, we're going to go for indent a b in tree print plus a plus b. Probably should just put this in an f string. This works. Actually. If this works. Where? All right. I gotta go, folks. Have a good night.